Hey guys, I just wanted to give you a hint on setting you up in problem number 9 in written assignment 5, and it has to do with length of curve. In this problem, this is a very sneaky U substitution, and there is actually a hint for you to do that. So the length of something is going to involve the derivative. So we know right off the bat that we would say y is x to the 5 over 4, so that the derivative is going to be 5 over 4 x to the 1/4. Okay, so with that, we would say the length is going to be integral from 0 to 1 of square root of 1 plus the derivative square. So we're going to have to square 5 over 4 to get 25 over 16. And then x to the 1/4 square is going to be x to the 1/2, which really turns into just square root of x. And we are integrating with respect to x. So that is the integral for the length. That's what we need to go and integrate. In order to perform that integration, we need to do a U substitution. In this case, the problem is telling you to go ahead and call U square being the thing that is inside the square root right there. The question is why, right? I'm sure there must be some reason why. It must work out nice. So let's trust that it will work out nice. Well, so then we say let U be 1 plus 25 over 16 square root of x. Okay, if that is the case, then we want to know what dx is so we can do the substitution, because that U square actually, because the part there is the square root right there is going to be square root of x of U square, which will give you U, right? So far, if we just think about that integral, we have the integral of square root of U square, and the question is, what is dx? Okay, what is dx? So that I can write that in. Okay, so let's go ahead and take the derivative of both sides here. So when we do take the derivative of both sides, we will have 2u du is going to equal to, the derivative of 1 is 1. The derivative of 25 over 16 square root of x is going to be 25 over 32 square root of x dx. Because we know that the square root, the derivative of square root is 1 over 2 square root of x. So 2 times 16 is 32. So from here, if we were to solve for dx, we would say dx is going to be multiply, right? So multiply 32 square root of x, we'll have 64 square root of x, and I'm going to divide by 25. So then that is dx. Now, it would be weird to have the square root of x right there. We want to go ahead and change everything into u. So we're going to have to say, well, let's go and solve for square root of x from here so that we can do a little substitution, right? So from there, we would say we would have right here u squared minus 1 is equal to 25 over 16 square root of x. Okay, so then multiply by 16 and divided by 24. So 16 over 25 times u squared minus 1 is going to equal to square root of x. So this right here is what we are going to put into here, square root of x. So we would say then, let's go back and write down what that means. So dx is going to be 16 times 64 is 1024, and then 25 times 25 is going to be 625 times u squared minus 1, and then we'll have u du is equal to dx. That right there is what goes in this blank right here. Okay, so with all that put together, we will have here 1024 over 625 multiplied by u squared minus u times u du. So that integral is going to be simplified to be integral of square root under square, and I can take the constant actually on the outside, so I will have 1024 over 625, and then I will have u times u times u is u squared times u squared is u to the fourth, minus u squared times 1 is u squared du. So now we see it. That's why we make that substitution, so that it becomes something really nice that we can go ahead and take the integral of. Now the question is the integral from where to where? Okay, so whenever we do a u substitution, we have a choice of go ahead and put it in terms of u, or to go ahead and put it back into x, and then we can use 0 to 1. Well, because u looking very nice right now, I wish I have those limits in terms of u. So let's go ahead and do a little calculation so that we can figure out what u is when x is 0 and also when x is 1. So let me give myself some room here. So when x is 0, we have u squared equals 1 plus 25 over 16 square root of x, which is 0. So u squared is equal to 1. And if u squared is equal to 1, then u is equal to plus or minus 1. Okay, now I'm going to write plus or minus 1. But we are just going to deal with the positive value because when x, as you can, I mean, if you really want to justify why that is, it's like when x is from 0 to 1 right here, the graph of u squared equals to 1 plus something is going to go like this, and another part like this, right? So we know that it would be best to just deal with the positive value, which is from 1. When x is 0 to 1, u go from 1 to here. Okay, so I want to say here, so I need to go find out what here is. And this down here is a negative 1, and this right here is a negative of the other value. So let's go find out. But we are going to just use the positive one rather than the negative. And then when x is 1, we would have u squared is equal to 1 plus 25 over 16 square root of 1. So u squared is going to be 41 over 16. So u is going to be square root of 41 over 4. Plus or minus, but again, I'm just going to deal with the positive part and not have to worry about the negative down there because it's going to yield the same result, right? So if we were going to use negative, we would go from negative square root of 41 over 4 to negative 1. But we're just going to go with the positive value because it's going to, because of that symmetry there, it's going to give you the same answer, square root of 41 over 4. Okay, so now here we would say going from 1 to square root of 41 over 4. Okay, so easy enough to integrate. That would be 1024 over 625, and the integral of u to the fourth power is u to the fifth over 5 minus u to the third over 3, and we are evaluating that from 1 to square root of 41 over 4. And if you throw that into your calculator, the exact answer is going to involve square root of 41 in it. But the decimal answer, if you throw that into your scientific calculator, it should give you approximately 1.4226. And that is the answer to number 9. Okay, but the learning process would be for you to use the substitution that they wanted you to use, right? And then so you get something that has the x's in terms of u and x all together. So you have to go and solve for square root of x so that you can do a substitution with just fully u in it. And this is why it's a sneaky substitution, a sneaky u. So then you solve for dx, and dx is this whole big part right here, and that is what you're going to substitute that into here, which simplify to be a very nice expression, right? So it will just be this with a constant in the front. But then you're thinking, well, if the thing with u is nice, then we wish the limit of integration would be also in terms of u. So we go and solve for u. So when you solve for u, you get these values right here, and that becomes your limit of integration. And then you will just be able to complete that integration real quickly because it is now going to be a nice thing to integrate. Okay.